Welcome to This Explainer. Today, we're diving into a surprisingly feisty, bare-knuckle street fight that's happening right now in the highest halls of academia. We're talking about a fundamental clash between modern theoretical physicists and philosophers. What actually happens when the people mapping the empirical laws of our universe decide they just don't need the people who map the rigorous rules of logic and meaning anymore? We are going to unpack this intellectual blackboard rumble, and I promise you, the stakes between empirical science and philosophical logic get surprisingly intense.
Let's jump right in by asking the ultimate question at the heart of modern foundational physics. As astrophysicist Adam Frank points out, this entire debate basically revolves around one massive boundary. What are the actual limits of science? Like, where exactly do we draw the line? Because empirical science, by definition, requires testable, observational data. Metaphysics, on the other hand, deals with the fundamental nature of reality completely beyond what we can physically observe. So at what point does a scientific question stop being about physics and start becoming a question of philosophy or even metaphysics?
That brings us to Section 1, the Blackboard Rumble, Krauss versus Albert.
Okay, so let's look at a very public clash that dragged this whole academic dispute right into the broad media daylight. It all kicked off with theoretical physicist Lawrence Krauss and the massive hype surrounding his book, A Universe from Nothing. When it dropped, evolutionary biologist Richard Dawkins wrote this wildly enthusiastic foreword explicitly comparing Krauss's book to Charles Darwin's The Origin of Species. So naturally, everyone braced for this huge, epic theological slugfest between atheists and theists. But that's not what happened. Instead, David Albert, who is a highly respected philosopher of science with deep expertise in quantum mechanics, completely savaged Krauss's book in a New York Times review. Albert bypassed the religious debate entirely. He went straight for the book's fundamental logical blind spots, hitting on the core difference between scientific calculation, which is the math, and philosophical logic, which is the meaning.
Which perfectly sets up Section 2, the problem with nothing.
Because, as it turns out, in the world of theoretical physics, the word nothing is doing a lot of heavy lifting. It's a hugely loaded term. If you're going to claim that physics can explain how everything came from literally nothing, well, your whole argument hinges entirely on which version of nothing you're actually talking about. When Krauss says nothing, he's using a very specific scientific definition based on quantum field theory, or QFT. In modern physics, quantum fields are the most basic fundamental entities of nature. All the matter particles we know about, quarks, electrons, the stuff that makes up you and me, they are simply manifestations of these background fields. So, strictly from a quantum field theory perspective, nothing just means a state of the field where there are currently no particles. It is just an empty quantum field.
Using this very specific definition, Krauss lays out a three-step process for the creation of the universe. Step 1, you start with nothing. Again, that no particle field state. Step 2, you apply the existing laws of quantum mechanics, which actually tell us that these empty states are inherently unstable. And step 3, because of that instability, you get a spontaneous jump to something. The field just erupts into configurations with lots of particles. So start with nothing, add quantum laws, get a universe. End of story, right?
Well, not exactly. Philosopher David Albert wasn't buying it for a second. He pointed out a glaring logical gap. Krauss's nothing is actually a very specific something. Think about it. Krauss is doing science here. He's operating mathematically within the rules of the existing quantum fields. But Albert is doing philosophy, asking the crucial underlying question, where do the fields themselves and the laws governing them actually come from in the first place? Treating a pre-existing physical field as nothing is a total logical failure, not a mathematical one. Krauss claimed to have solved the ultimate mystery of existence, but Albert pointed out that he entirely missed the philosophical point by simply assuming the existence of the physical laws and fields right out of the gate.
And that friction leads us to Section 3, the anti-philosophy trend.
Now, you might be thinking this was just an isolated argument over one book, but it's not. It actually highlights a much broader, deeply ingrained trend within the modern physics community. There's this growing, honestly pretty dismissive attitude toward philosophy among some of our most prominent scientists. Instead of engaging with the logic of David Albert's critique, Krauss went on record in a highly controversial interview with The Atlantic and literally called his philosophical critics moronic. He heavily implied that the entire field of the philosophy of science is just completely useless to modern physicists.
And Krauss is definitely not alone here. Take Leonard Susskind, an absolutely brilliant theoretical physicist. In his book, The Cosmic Landscape, Susskind proposes these radical ideas based on string theory, and he relies heavily on the anthropic principle. That's the idea that the universe has these specific laws simply because, well, if it didn't, we wouldn't be here to observe them. It's a deeply contentious and philosophically loaded concept. Yet, when he's confronted with the massive philosophical implications of his own theory, Susskind basically just waves his hands, writing, "Frankly, I would have preferred to avoid the philosophical discourse the anthropic principle excites."
So what's going on here? Well, physicists like Krauss and Susskind often feel they are proudly channeling the legendary physicist Richard Feynman. Feynman possessed a notoriously deep scorn for the philosophy of science. He famously believed it was totally immune to making any real progress. His vibe was very much shut up and calculate, prioritizing the math over philosophical logic. But there is a massive problem with trying to apply Feynman's attitude today.
Let's look at why in Section 4, Untethered from Data. The reality is, we aren't in Richard Feynman's era of physics anymore. There's been a fundamental shift in how cosmology is conducted today, and it perfectly illustrates the boundary where empirical science ends and theoretical assumption begins. Think about it this way. If you're a physicist exploring carbon nanotubes, sure, you can happily ignore philosophy. Your work lives or dies by the empirical, real-world experimental data you collect in the lab tomorrow morning. But modern foundational physics? It is entirely untethered from that kind of immediate data. Theorists are proposing ideas where detailed contact with experimental data might be decades or literally centuries away. Without that data, they have to rely primarily on pure mathematical consistency. And because of this profound lack of data, we've seen the rise of what Adam Frank calls celebrity cosmologies. We're talking about string theory, hidden dimensions of reality, the multiverse, these infinite possible parallel universes. These are incredibly popular, wildly radical revisions of reality, but because they cannot currently be tested with empirical experimental data, they are skating on incredibly thin scientific ice. In fact, you could strongly argue they are crossing the line from empirical physics straight into metaphysics, the philosophical study of reality beyond what we can physically observe.
Which brings us to our final point, Section 5. Why philosophy still matters.
Look, when you are proposing infinite multiverses that you cannot physically observe, simply dismissing philosophy is a terrible way to map this exotic new terrain. It really helps to understand what the philosophy of science actually does. It isn't trying to do the math. Instead, it rigorously explores the relationship between what is theoretically possible and what is actual. It meticulously polices the logical links between an argument and its conclusions. It meticulously examines the tension between grand theoretical models and the actual evidence claimed to support them. When you are in a completely data-starved environment, this kind of logical rigor isn't a distraction, it's literally your only compass. And here is the most fascinating takeaway of this whole explainer. You can't actually escape philosophy. If you ignore it, you just end up doing it poorly. Cosmologists who dismiss it almost always fall prey to their own unspoken philosophical biases and misconceptions. Now, some physicists, like Sean Carroll, deeply understand where the domains of science and philosophy converge, but others? They push so hard at the boundaries of fundamental concepts that they cross over into metaphysics completely blind, getting lost in their own unexamined assumptions. Ultimately, exploring the exotic new terrain of our universe requires intimately knowing exactly where the boundaries of your discipline end. We need the math, absolutely no question. But as we continue to push the absolute limits of fundamental physics into unseen realms that we cannot currently observe or test, can we really afford to leave wisdom behind?